Welcome to Managing Kanban. In this video, we'll look at Kanban from a project manager's point of view. In our last videos, we demonstrated that we can use Kanban to develop software. However, Kanban is primarily a process management tool. This means we can use it to manage the whole project, not just the coding part. Project management with Kanban requires us to think differently, though. It's something of a paradigm shift. One major aspect of project management that changes when we use Kanban is scheduling. In this figure, the time for the project is on the x-axis, the people needed to do the work is on the y-axis, and the area of the blocks are the man-hours that particular task needs. Normally, scheduling a project entails a balance between time, money, and people. Having more money allows us to hire more people. However, that isn't always a fix. In general, we schedule by taking all of the tasks that need to be done and distributing them between the start and end of the project. If something happens to disrupt the schedule, and something always does, the tasks towards the end of the schedule tend to be rushed through and suffer quality loss. If those tasks are critical to customer approval, we risk project failure. Kanban has a different approach. We figure out what the absolutely necessary parts of the project are and do those first. These tasks make up the minimum viable product, the absolutely must-haves. Until these are done, we don't even look at the other requested features. When the MVP features are done, we look at what the project's should-haves are and do those. Then we consider the could-haves, stuff that would be good to have, but if it's missed, it's not all that important. And finally, if there's time, the would-likes. These are things that make the program really nice and give it polish, but no one will really notice if they're missing. Now, if we have that same task grow on us, we only lose one of the could-have features rather than the must-have feature. Kanban prioritizes and does the important things first to make sure that they get done. Using Kanban may result in cutting features from your product, but they'll be the least important features, maximizing the acceptance rate from the customer. Since Kanban only looks at the vital things first, changes in requirements aren't such a big problem. If a must-have requirement shows up in the middle of the project, the purple box for this graphic, it's done next. It takes priority over all the should-have tasks. If the purple box had shown up later, we'd have lost some could-haves, but still would have gotten the vital piece in. If the change is lower in priority than what we're currently working on, all the better, as we haven't done any work at all on the original requirements yet, so we've wasted no time at all. By prioritizing the features needed in the minimum viable product and working only on what's immediately needed, we minimize the effect that unforeseen events will have on the project. Anything that slows work down, such as loss of a team member or some project component not being delivered on time, results in a low priority feature not being added, rather than a failed project. When there's a holdup on a particular task, it's moved to the tracking column. Tasks in the backlog that depend on it are moved down in priority, and work on other things continues. When the problem is resolved, work on that task restarts, and the dependent tasks are moved back up in priority. Unexpected new requirements or change orders can be addressed at their appropriate time, with new MVP requirements being put at the head of the backlog and less urgent ones handled when their priority comes up. When we're scheduling, we look at the tasks in the must-have category first. The time estimates written on the cards give us an idea of how much time the MVP tasks will take. This tells us if we'll be able to address the should-haves or if we'll just get the minimum viable product done. We can also look at the tasks which will require our expert and arrange the cards so their workflow is smooth. Once the tasks in the minimum viable product are prioritized, we stop scheduling until the last must-have task is near the top of the backlog. Then we look at the should-have task cards and repeat the process. This way we don't waste any time on features we'll never get to anyway. If we're working on the should-haves, could-haves, or wants, and don't have time for all the tasks, we can immediately drop tasks that have an estimated time larger than the available time and ask the customer which of the remaining tasks they want done. The estimated time will allow us to figure out what combinations and permutations are possible given the available time. While we've used a fairly simple project in our demonstration, Kanban can be applied to complicated projects with multiple teams. In these cases, the project manager can use a compound Kanban board. We make a Kanban board for each of our groups and put them inside a larger Kanban board which covers the whole project. The individual boards work like swim lanes for the larger project. The Kanban boards for the separate processes can have different steps, numbers of steps, column names, and work in progress limits. Why use Kanban for project management? Doing so may require a change in company culture, and changes like that are not easy. The learning curve for those used to the waterfall method can be steep. Kanban has a number of advantages over traditional methods. One of the biggest advantages is quality control. Since the important parts of the project are done first, when the amount of time and enthusiasm is greatest, those parts are likely to have the highest quality. As the project progresses, management can decide if they need to speed things up at the cost of quality, or if they would rather drop lesser desired features and maintain a high quality. Another benefit is that since the customer decided the features of the MVP, they're aware of the minimum they'll be getting. This allows us to underpromise and overdeliver, which always makes customers happy. Thus, using Kanban makes for higher customer satisfaction. Finally, since Kanban boards make the whole process transparent, and we only focus on what needs to be done right now, there's a lower stress level and burnout rate for workers, management, and the customer. Lower stress levels make progress sustainable. Project management with Kanban also allows a constant measurement of how the project is doing with multiple metrics depending on what aspect of the project we want to look at. Here are some more commonly used metrics that Kanban provides data for. 1. Making the size and complexity of tasks uniform allows us to accurately track throughput of work at whatever granularity we choose. 2. Tracking the number and time cards spend in the Done column helps us determine which work in progress limits need adjusting. 3. The tracking column highlights which tasks are having issues that we may need to address. 4. We can use data on the estimated versus actual time to adjust our estimating process and make it more accurate. 5. Comparing the total time it takes for a card to navigate the system to times between any 2 points help us better understand the process and allocate resources. 6. Cumulative flow diagrams show how many cards are in what column in different colors to help us identify bottlenecks before they happen. 7. Control charts can focus our attention on day-to-day operations so they can be addressed by the daily stand-up meeting. It also helps identify long-standing problems, which tend to be seen just as the way it is, rather than something that can be addressed. Let's look at these metrics closer. Making tasks fairly uniform in size and complexity is important to managing a project using Kanban. Uniform tasks make the workflow more uniform throughout the development process and helps us track progress. If tasks are different sizes, we can't know if the task is delayed because it's bigger or if there's a problem that needs addressing. Uniformly sized tasks make a card equal to a set amount of work and allow every other performance metric to work. One of the easiest metrics to use is to look at the throughput of cards. Measuring the throughput of cards gives us the rate that the work is being done. We have to be careful, though, as a rising number of cards coming through can be misleading if the amount of work on each card is being reduced. We need to keep in mind not only the number of cards coming through, but ensure that the work represented by each card stays the same. We know we have to make tasks the same size, and that size determines the amount of work a card represents. But what size should that be? Task size determines not only how much work a card represents, but how finely grained the project management is. If we make the task size too small, we risk micromanaging, which stifles the creativity and stresses out the developer. However, if we make the task size too large, we allow chaos to creep in, and the developer can feel overwhelmed. In Kanban, we want each card to represent work that can be done in 8 to 16 hours. That still gives us a considerable flexibility. We need to pick an amount in that range that will fit our team and management style. One big warning flag that we need to adjust our work in progress limits is the amount of time cards spend in the Done column. Those are tasks that should be moving forward. Ideally, cards would spend no time at all there. There are 2 fixes to a lot of cards in the Done column. One is to decrease the work in progress limit for that step, and the other is to increase the work in progress limit for the following step. Which is correct depends on why the cards are spending so much time there. Let's look at some reasons which indicate that we need to lower the limit on that step. Fun activities, like coding, are sometimes done at the expense of necessary but not so fun activities, like testing. In this case, we need to drop the work in progress limits for the coding section. Another time we want to drop the limit is if the previous done section stays clear, but we never get close to the limit of the step. This means we set the limit unrealistically high. This could happen if we don't have an accurate idea of how long the process takes and estimated too much time for that step. Work in progress limits should get hit sometimes, but being constantly at that level indicates a problem. If the people working on one step are significantly more productive than people working on the following step, the cards will build up in the done section. Instead of changing the limits, we may want to reallocate resources, giving the team working on the second step priority for limited resources, or moving some of the people from the first set to the second one would help in this situation. It'll reduce the speed of the first team and enhance the production of the second, making the workflow more even. Since the primary cost for software development is the salaries of the developers, time is money. Cross-training people to help reallocation of resources not only makes the project move quicker, but saves money and makes your people more valuable. If our work in progress is constantly at a maximum for a given step, and the previous step's done column has cards in it, we need to raise the work in progress limit for that step. This may mean that personnel need to be added to that part of the process as well. No matter how well run the project, something always goes wrong at some point. That's why Kanban has the tracking column, whether it's a specialist that's out with the flu, or there's a decision that needs to be made by the customer. Problems happen, and many are unavoidable. Kanban's tracking column allows the problem to be set aside while work on other parts of the project continues in an uninterrupted manner. When cards are in the tracking column, we may need to rearrange the cards in the backlog if the task in backlog depends on the task being tracked. Cards in the tracking column need to have an eye kept on them. It's possible that the problem could be resolved without anyone noticing. For example, if the team was waiting for a test account to be made for them on the customer's database, that account could be created with no one on the team knowing. The project manager should make sure that the problem is tracked and the status of the cards reflects the current situation. Bringing them up in a stand-up meeting is appropriate. Another thing to watch for is if we have a lot of cards in the tracking column. This may indicate a problem that needs addressing, such as a communications problem. Discussing tracked cards in the stand-up meeting will reveal this problem, as we'll frequently hear, "Oh, waiting for a word from so-and-so." Most of what we've covered so far is stuff that good managers would figure out on their own eventually. Let's take this one step further and look at some data-driven metrics we can use after we've accumulated a little data using Kanban. We'll look at the average time for each step and the total time for a task to make it through the system. We can bring in some statistical analysis to enable us to make predictions, which is handy when the customer asks, "How long is this going to take?" We'll look at cumulative flow diagrams and see how they can help us find and prevent bottlenecks, as well as give us a visual on timing and ratio of tasks done to not done. Finally, we'll look at control charts, which tell us how well we're performing compared to our average, and the effect that changes in practice make. First, let's look at cycle time. Cycle time is the time between any 2 points in the process. We can compare the time in analysis to the time in coding or testing. Seeing how long the various parts of the process take allow us to make better initial work in progress limits. Because we have a better idea of how many tasks can get through testing during the same time that 3 tasks get through coding, we can raise or lower the work in progress limits until the flow is smooth. When we add the times together, we have the time the task actually is worked on. We want that time to be about 1 to 2 days. If the total cycle time is longer than that, we need to break the task down further. If it's shorter than 1 day, we're starting to micromanage and we need to back off some. We can also look at how cycle time changes over time. This can be something of a guide to the team's productivity and feedback on how changes to practice affect the functioning of our team. If we change to pair programming on August 3rd, did that speed up or slow down our coding step? Here's an example chart showing the average number of hours spent per task in each step. We made a change to our practice on September 3rd. While the data is still pretty noisy, we can see that the average time for all 3 steps has dropped, which is the type of improvement we're looking for. Another thing we can look at is the variability of the averages. The high variation could be either non-uniform task size or complexity, changes in team dynamics such as absences or interpersonal strife, or changes in management technique. To make sense of the chart, we need to be taking notes about what's going on with the team. The peak in the analysis section for the week of August 4th could be due to a team member's absence, analysis team members working on coding or testing tasks, or team members getting used to a change in practice. We can check our notes to see if somebody was reallocated to another department, if there was a flu going around or somebody attended a conference, or if there was streamlining of the analysis process. Lead time is the amount of time it takes for a card or task to make it through the system. It starts when the card is created in the backlog section and ends when the product is delivered to the customer. It gives us a general feel for how long it takes to respond to customer requests and changes. Comparing the lead time to the time the task is worked on can show us if we have too many cards in the backlog section or take too long to deliver finished products to the customer. Keeping track of estimated versus actual time it takes to do tasks gives us an idea of how accurate our estimation process is. Even though we try to get tasks the same size, no job will be perfect, so we need to use a percent error calculation. The positive or negative sign will tell us whether we over or underestimated the time, with a positive value being an overestimation and a negative value an underestimation. The goal is to be as close to 0 as possible. A spike in the graph means something went wrong to throw off our estimate. That's not really a concern because it's bound to happen in a normal progression of a project. What we want to watch for is a long-term trend of inaccuracies in the same direction. In this case, we have considerably more and larger positive values than negative ones, so our team has a tendency to overestimate how long things will take. While this is better than underestimating, it's still not as good as being accurate. One thing to watch out for is that with percent error calculations, being off by a small amount, such as an hour, will give a much larger effect for a small job than a large one. So if we're not good at keeping the jobs a similar size, the data will be less useful than it could be. We can go one step further and make a histogram of the estimation errors. If we keep track of who made the estimates, we can see who is overestimating and who is underestimating. Looks like we need to remind Yoshi that not everybody codes as fast as she does, so she needs to add some time to her estimates. And Rico, on the other hand, tends to be too conservative. We can look at past data to get an idea of how long it takes our team to do any particular step. Let's look at some coding times. Here's a histogram of coding times for previous tasks. This is a little hard to read. Since the time it takes to code any particular task is pretty independent of any other task, we can model this as a normal distribution. Using a weighted mean time of 7.2 hours and a weighted standard deviation of 2.7 hours, we can generate this figure. In reality, nothing exactly follows a normal distribution, but it helps us estimate and gives us an idea of how our team performs. We have a 68% chance that any specific task will take between 4.5 and 9.9 hours, and a 95% chance that any specific task will take between 1.8 and 12.6 hours. We only use 2 standard deviations, as the remaining 5% of the tasks are outliers and can't realistically be predicted, especially when this is an estimate to start with. We can generate these graphs for both lead and cycle times. The lead times are useful in estimating the time of delivery for a customer. The cycle times are good for internal project estimates and deadlines. Cumulative flow diagrams show the number of cards in each step over time. Ideally, only the completed section should grow. The steps in the process should maintain uniform thickness, as they should have close to the limit in cards at all times. Let's look more closely at this section of the graph. Moving horizontally gives us time. The lead time is the distance from the backlog through product delivery. The cycle time is the width of a color band. Moving up and down gives us work. The distance from the backlog to the top gives us the work in progress. The distance from the plots to the dashed line on top gives us the amount of tasks that need to be done. When the scope of the project increases, that dashed line goes up. The big thing that indicates problems on the cumulative flow diagram are bands that are not uniform in width, as that indicates non-uniform workflow. In this diagram, that's primarily in the testing band. First, we have it growing thicker. A thick band means there's many cards in testing. This implies that some of them are spending way too long in that step. This could be due to a team member being absent, or cards from coding needing extra work before they can make it through tests. Time to talk to the testing team and see why it's taking so long for them to move cards through. At about the same time, we have a peak in the backlog. This could be due to a transition from must-haves to should-haves, or a surprise MVP requirement that has come in. Since neither of these are reason for concern, we don't need to do anything about that. Finally, we have a spot where the number of cards in testing is very low. Since the other steps have the same number as always, we could be having a work slowdown. Time to check the done column for coding. If there's plenty of cards in the done column, we need to look at why so few are being moved to testing. Finally, we have control charts. Control charts show the time progression of cycle times for tasks. We looked at that already, didn't we? But wait, control charts are those charts evolved one more step. We have the date on the x-axis and the time a task takes in a step on the y-axis. The task itself shows up as a dot. The expected value, which is the mathematical average, is the red line. The shading shows 3 standard deviations, which should enclose 99% of the tasks. The green line is the actual weekly average time of tasks spent in that step. By including both the actual data points as well as the average, we can look at spots where the actual average was far from the expected time and see if there's a single task that was the problem or not. We need to look at the outliers. They'll either have a specific cause, such as Yoshi was out with the flu that week, or a common cause. If there's a common cause, that is, the performance is just not uniform, we could be looking at a systematic problem, and we need to think about process improvement options. We can use control charts for the following. We can analyze the team's past performance in a retrospective. We can measure the effect of a process change on team productivity. In this case, we brought in that specialist on September 3rd. We can see that average time went down when they joined the team. We can provide external stakeholders with visibility of the team's performance. And we can use past performance to set future goals for the team. All of these metrics can be performed using a spreadsheet. However, there's a number of electronic Kanban tools available that will process the data for you. We aren't recommending any one tool over another. In fact, we aren't recommending any at all. Electronic versus paper Kanban boards is a choice that depends on your specific work environment. If your whole team is physically close to each other, the large paper board will be more visible, and physically moving the cards somewhat of a symbolic victory. However, using a paper board means more work for the project manager if they want to use the metrics we've discussed here. The electronic board records the data for you so that the metrics can be viewed easily. It's also a good idea if your team is distributed geographically. Let's have a quick review. We looked at how Kanban addresses the most important tasks first, which results in better quality control, a higher customer satisfaction rate, and lower stress levels for everyone. We can use Kanban in complex projects by nesting team Kanban boards into a larger project board. The amount of work placed on each card has to be uniform so that we can associate card movement with work being done. We talked about how to tell when work in progress limits need to be adjusted and/or resources reallocated. Finally, we discussed some of the performance metrics that are possible to use in Kanban. We hope you found this presentation to be informative.